Hi everyone and welcome back to Inside AMG. I'm on my way to Brixworth now to Mercedes-AMG high-performance powertrains to take a closer look at the development and the production process of not just the Formula One car's powertrain, but also the powertrain of the Mercedes-AMG 1, which is on the streets right now as we speak. So there's a lot to look forward to. Stay tuned.
Hey Felix.
Hello there, Adam.
Nice to see you.
Nice to see you too.
You well?
Yes, I am, and I have to say I'm very excited to be here today. And
Welcome to HPP.
Thank you very much. I'd say before we set off, why don't you tell the people at home? I mean, many people probably already know you or recognize you, but why don't you tell the people at home what it is that you do here?
Okay.
What your position in particular is?
Sure. So I'm the Advanced Technology Director here. That means I'm responsible for Project 1, EQXX, Formula E. I spent 10 years prior to that as part of our Formula One group. So I know HPP really, really well. And I'm honoured to be able to take you through what Formula One's about, what Project One's about, and how that links with AMG, because our relationship with AMG has got really, really close over the last years.
Perfect. That's what we're looking for today, to also build that bridge between Formula One and AMG, and that's a very strong bridge. And I gotta say, there's so many interesting pieces that I've already seen walking in here today. I don't even know where to start. I mean, these alone, well, that's what it's all about, right?
Absolutely.
The power units.
So let's start with what we do here. We're really vertically integrated. What do I mean by that? We have an engineering office on the first floor here. We start with simulation, clean sheet simulation, really high level, CFD, so computational fluid dynamics, looking at combustion, looking at NOx, fuel injection, so some real deep thinking. Our performance simulation leads into design, turning the ideas into designs that can be made. We've got a large manufacturing hall that I'd like to show you a little bit later on.
Nice.
Okay. The reason we make a lot of our parts internally, IP, it means we can keep our secrets, really important for racing. Speed, because our race is against time and we've got some fierce opponents. And then flexibility. We like to give our engineers all the tools they need to come up with the best designs, the most creative designs. And so that gives them freedom, because they can go and stand with the person that will engineer the manufacturing solution to come up with those parts. We then bring the parts back over here, downstairs, we assemble them into power units. They go for testing on our dynos, and then we'll bring them out and put them in Lewis's race car, put them in George's race car, and off we go.
That's brilliant. All the know-how condensed in one place. How many people are actually working here?
We have about 900 people.
Wow.
Not all Formula One, so that covers Formula One, Formula E, Project One, or as AMG One, as it is now, and EQXX.
Ah, okay, cool. And why did you, select Brixworth, or was it really a process of selection, or it probably has to do with the history of the company as well?
Yeah, exactly. We started life as Ilmore. That was Paul Morgan and Mario Willian as our two founders. Paul actually lived in Brixworth, which is a mile over the way, and there's quite a rich seam that's often called Motorsport Valley that goes from, we're at the top of it, and then it goes down through Oxfordshire, so you go past Brackley, and where we've got Mercedes GP from our chassis partners. We go down and you've got Williams as you go through Oxfordshire, and then right down to McLaren. So there's a lot of motorsport, and then a lot of club motorsport as well, not just Formula One. And what that means is we've got great amounts of talent that are interested in motorsport, but then we've got a supply base as well. Lots of suppliers that are used to the crazy things we ask for, the crazy times that we look for things to be done in.
Crazy and pretty cool as well. I mean, no matter where you go here, you always feel that buzz in the air and the passion for motorsports. It's all around you. That's pretty cool. And I gotta say, we have to talk about these things right here. That's so interesting. This is like, it says it's the 2014, so the first generation of hybrid powertrain.
Yep,
this
absolutely. So this is actually Lewis's championship-winning powertrain.
Wow, nice piece of history here.
This is a huge piece of history. So this was called the GD engine. Let's talk about what's in a power unit. So we've got a 1.6 litre V6 combustion engine.
Many parts I recognize instantly from a regular combustion engine.
Sure.
Looks very familiar, yes.
We've got quite simple exhausts on it, log exhausts at that point. It's a turbocharged engine, so you may see there's a turbocharger right in the middle, but it's not in the conventional position. We actually split the turbocharger, as I'm sure you know.
Yeah.
That allowed us to package it lower, which helps with the centre of gravity, and it meant we could put what's called the MGU-H, so an electric motor, right behind the compressor, which is at the front of the engine there.
Ah, okay, I see.
And that is what then led into some of the idea of having the hot V that AMG have adopted.
Exactly.
Electrically assisted boosting, which helps with turbo lag. So that was our first journey really into that.
That's pretty cool to see, like all these different parts that made their way into the road cars. They started out here on the F1 engine.
Yeah, exactly.
Pretty cool.
And so at this point, the regulations were largely the same as they are today. Yeah. So we've got a V6 combustion engine, turbocharged. We're allowed an MGU-H. We can't have a variable geometry turbocharger. That to keep costs down. We've then got what we call the MGU-K. So the MGU-H is heat recovery. It can either absorb energy from the turbocharger or deploy it to basically give instant throttle response, so we can charge the air path. The second electric machine is down here on the lower left-hand side, so that's called the MGU-K. So that's geared straight onto the crankshaft.
Oh, wow.
If you look at the size of that, that's a 120 kilowatt electric machine.
That little thing right there.
Yeah, so about 160 horsepower, 120 kilowatts.
That's amazing.
But then you can see the orange HV cables going out to the front. So we have to do something to control the electric machines to provide the power that they need. So on the bottom, we've got a battery. So all of our cells are on the lower layer of our module here.
Ah, okay.
And then on the top is all of our power electronics. So the inverters to turn the DC electricity from the battery into AC electricity for the electric machines, but also all of the brains for how those motors are controlled lives within the electronics on the top.
It's all integrated into that box.
It is.
So this is already an actively cooled battery pack, so to speak. So something we already talked about in previous episodes on Inside AMG, active cooling, which we also employed on the road-going cars.
So our cells, liquid cooled, end cooled, which has then been adopted. It's great for performance. It's great for managing the heat coming out of the cells. We also use that for cooling the electronics underneath. So it's not flooded electronics, it's only the really high power parts. This then helped us with the air cooling because the air wasn't circulating, it wasn't getting cooled, and the heat rejection was higher than we anticipated. So this was the start of our journey with the V6 power unit.
Really cool.
And you might say that the regulations have largely stayed the same, which they have, but then if we look at this power unit, this is a 2018 example.
So still, regulations stayed largely the same between 2014 and 2021. Only in 2022 did we have major changes. These are from the same rule book, more or less, but they look completely different.
Yeah. So some of those changes were because of the rule book. Some of those changes were just through our constant pursuit of innovation, constantly looking at how can we get a few more milliseconds, how can we improve the efficiency a tiny bit. So the exhaust, for example, we've changed the packaging at the rear a lot, and you can see the primaries coming out of the exhaust totally different compared to 2014. That was part of, enabled by part of the rule changes that allowed us to have variable plenums, as they're called. So this carbon section on the top, that's the air plenum. You can see it's much larger. We had a rule change that allowed us to go to what's called a variable plenum. Okay, that means you can actively change the tuning length of the engine, which gives you better performance. You match that with the exhaust, so the whole air path there you can see is very different. If you look at the module, the cables, they're a little bit narrower. We thought we could take a little bit out of them, save a bit of weight. Every little bit of attention to detail is so important. What you can't see, the horrible late addition on the module we just spoke about, that was then integrated, so that's now done nicely. But there's a whole host of functions that we then built into the module that were previously distributed around the car. So that meant fewer boxes around the car, fewer cables, lighter weight. So it's a constant push to say, how do we get more functions into the power electronics? How do we get more efficiency so that we've got less heat rejection? Because what our chassis partners want, they want the power unit to be tiny, not weigh anything, provide loads of power, and reject no heat.
The best of all worlds.
Exactly,
basically. Yeah.
exactly. Yeah, because the more heat we reject, the bigger the radiators, the bigger the side pods, the slower the car. Which kind of brings us to 2022.
Exactly.
So we've had some big regulation changes for 2022, massive on the chassis side. We've had some reasonable regulation changes power unit side as well. So the chassis side, we've worked really closely with our colleagues at Brackley on how do we get the optimum race car. We don't want the best power unit or the best chassis. We want the best race car. So the aero changes have impacted the power unit. Then we've had to go to what's called an E10 fuel, so it's 10% ethanol. That means there's less useful energy we can get out of the fuel. So how do we recover that power? How do we then turn that deficit into creative ideas to get us back
That's
to
a
delivering
major
the same
challenge.
level of power? Absolutely.
Yeah.
Then the final aspect of that is this year we have to homologate our engine. So where I said we've gone through various phase updates in previous seasons, we can now only do that for reliability.
Oh, okay.
But there's someone who knows far more on that than me. So I'd like to introduce you to Pierre. Pierre's our chief engineer who's responsible for all of this power unit for racing this season.
Nice. Let's go and meet him.
Let's do that.
Awesome.
Morning, Pierre.
Morning, Adam.
How you doing?
Morning.
Can I introduce you to Felix?
Hello there.
Nice to meet you.
Nice
Welcome.
to meet you. Thank you very much.
One really important thing. He's going to try and get all of the secrets out of you. Be careful what you tell
Good
him.
luck.
And I'll see you later.
You just say whenever there's something you can't tell us anything about, but to kick things off, why don't you tell the people at home what it is they actually do here at HPP?
Yeah, so I'm chief engineer for the current project, so looking after the whole powertrain for this racing season.
Awesome.
And I've been here about 20 years. Yeah.
Nice,
Yeah.
nice.
So I'll show you what we do the design work.
Cool.
And all the, where it starts really. So that's where all the engineering happens.
There's a lot of people,
That's
a lot
right,
of
yeah.
desks here.
So in here, it's a massive open plan, as you can see, which helps communication, and we find it's so much better for people to interact and find the right information at the right time, and even information they didn't know about. But within this office, we've got all the different teams that help defining the powertrain. So we've got design, mechanical engineering, simulation, metallurgy in the middle. We've got the performance guys, we've got the program managers that also helps links everything together, software people, electronic people, and it's an awesome group of people that can just work together, and it's like a massive playground really.
Super nice. I mean, Adam already told me about the high level of vertical integration, and now looking at all these people working here, I can really see it come together.
It's all about optimizing how much time we can save by just having the communication at the right time. You know, we don't have to wait for a meeting or a phone call. It's just quite impromptu. Yeah.
Makes sense.
And I'll
Nice.
show you a bit more at the end of the office over there
yeah.
as well. So it's always quite lively in here. We're forever waiting for things to calm down a bit, but the way the season's been happening, it's been quite busy, and obviously we're not performing the way we want at the minute. So there's a big push to make sure we can extract as much as we can from the powertrain. The changes for this year have been the fuel. It's been a big change. So we've had to start using E10 fuel, same as the road car, same as which is great, you know, for the future and the vision. That's exactly the right thing to do. But for us, we were blessed. We had the easy life of having the fuel we wanted, and we'll see extract even more performance out of the powertrain. But E10 has been quite a challenge, and the big part of what we have to do for this year, this season.
As a driver of a road car, or somebody who's familiar with road cars, I already know that E10 poses quite a few challenges, and
That's
to
right.
imagine how challenging it's going to be from a race car perspective, I mean...
That's right, and we've seen already some of the teams have had some issues to adapt to that, even on the race car integration as well, you know, temperatures and stuff like that. So it's been a challenge for us, as well as trying to recover the performance we lost. And then the other thing we've been very busy on ahead of the year is adapting to a new car with the new aero regs. We're expecting quite a few challenges. The car's running much lower. We've done quite a bit of work to make sure the engine could survive. Historically, the past few years, the engines never really touched the ground because the car was on a high reg, whereas this one, we're expecting the chassis guys to run quite low, and we've seen that a lot already. So lots of structural work to make sure the engine wasn't going to break when that happens. And the other thing we've had to get ready for is this year, 2022, is the start of the homologation for us. So we got 4 years over the same powertrain. So we've tried to protect for car improvement. So trying to say, okay, by the end of the 4th year, what do we need to survive in terms of duty cycle.
Yeah.
And that's been quite part of the challenge as well. So we ended up kicking off the powertrain design project much earlier than we would have had usually.
Oh, okay.
Just to enable us to make sure that we arrived ready, and even then we got surprises. So it's been quite busy.
Yeah, there's been a couple of surprises. I mean, all the teams were struggling with the regulation changes. That was obvious that there were some things that you just couldn't foresee. And you already talked about the aerodynamic changes. I mean, that's what everybody sees. The car obviously looks very different than it did the years before. And Adam already told me that it's always a matter of integrating the powertrain into the perfect race car. So all these aero and regulation changes on that front, how did that impact you guys on the powertrain side?
So as I touched on, so make sure that we could cope with the car running lower, so more bumps on the bottom. That's one of the things we tackled. But afterwards, it was perhaps a bit more the normal process of integrating with the car. So there's a big sensitivity to aero, so we try to make the powertrain as fitting to what they need and move that out of the way. And that's the ongoing challenge, and that also helps with the good communication with the guys in Bracket as well. That's settled. That's day to day, if you want, with those guys. So that's what we've been doing as well.
And we already touched on heat distribution and heat exchange from the powertrain and how much heat it actually produces and disperses, and how you optimize that over the years until 2021. Now the 2022 cars, people have been talking about the lack of side pods pretty much.
They've done well, haven't they? They've done very well.
Does that also have to do with like how much cooling has improved, or how did you end up with a concept like that?
Well, what they've done very well is they've managed to keep our cooling requirements whilst delivering those shapes. So that's been awesome, I think, on that.
Nice, pretty impressive, and also great to see how many different solutions the teams find. To
as an engineer, you look at their side pod concept and think this is neat. So,
Awesome, cool.
So we'll go. So that's where the parts are designed and created, if you want, and dreamed about. And then we'll now move on to the manufacturing place, where we actually change those parts into reality.
Nice, let's go.
Let's go, yeah.
Awesome.
So we're now going to go to the manufacturing hall, which is where we make those parts, manufacture those parts. And the philosophy of doing everything in-house it started like 20 years ago, when we realized that if you're in charge of your own destiny to manufacture the part, you can react so much quicker rather than queue at the supplier. And that's when we started to grow what we're going to see about the manufacturing hall. And it's a fantastic facility.
Nice, yeah, I guess it makes a lot of sense to integrate it all like that.
Exactly, yeah. All under one roof. And also, again, it helps with communication and gelling with people. You know, you engage with people.
And secrets stay secret.
Exactly. So we'll see what we've built over all those years in order to react.
That is huge.
That's I always enjoy the view there.
Wow, that's like a flight hangar just filled with machinery.
And if you were to start from scratch, you'd be in for a big task, I think.
Wow.
So in here we manufacture pretty much everything in the powertrain, and that's run 24/7, and therefore it gives us the best reactivity that we can dream of.
That is just crazy, and you get the parts like instantly. You come up with something on the drawing board.
It means that when we're in trouble, we talk about contact time. So the part never touches a bench or anything. That's what enables you to go as fast as you can.
Wow.
And that's why we're able to switch on by having the right people at the right time at the right place, just to save the maximum time when you go trouble.
So full speed in every aspect. I mean, not surprising, really, considering how much speed you got to gather on the track. And
it's a development race, you know. So we're racing with the other guys. If we got the best facility, and to be fair, the people are so engaged that it's all one big team pulling together.
That is so cool. Awesome.
And you can see that there's robots moving parts around. There's inspection on the side with temperature control areas. And it enables us to protect the IP. Engage with people, having the right culture and the right processes. We got a few specific processes that makes us different. They enable us to push the part that bit harder, and that's gold for us.
How many people are working here? You said like it's running pretty much 24/7, right?
That's right. It's probably, I couldn't tell you exactly how many people there are, but we've had to organise ourselves such a so it's non-stop.
So what's the different materials you're working with here?
Anything from you could say engineered plastic to steel, aluminium, titanium. So not so much carbon on the powertrain. We got a few components are made of carbon. but it's mainly because
Many
they're quite high
different
duty.
metals.
Yeah, they're highly loaded, and as soon as you get to, you have to run to a certain temperature, you have to reach for metals anyway. So yeah, there's a few components that we can run in plastic and carbon, but otherwise you need to reach for metal.
Nice.
Which is a challenge. You know, whenever
Yeah.
you want to come up with a shape in metal, you need cutting machines,
Yeah.
and that's where that comes from.
Cool.
So we're now going to go down to the to where that gets built and tested.
Nice.
Next week.
Nice. Let's take a closer look.
Yep. So we've seen where the parts are being designed. We've seen where being manufactured. I thought next we could take you to where they're being assembled and tested.
Nice.
So we're going to need your help to put a water pump on an engine.
Really? I'm going to get to wrench myself?
That's right, yeah, we can trust you with that. I think.
Nice. Nice.
Let's go to the assembly area. And this is also where we build the AMG1 powertrain.
Oh, these are AMG1 powertrains.
That's right, yeah. So in the same building, and the powertrain are so similar that it just makes sense. There's no change for us. We can build one of those, or the Formula 1 powertrain. And
That is so awesome. Everything under one roof.
under one roof, and they are very, very similar. Yeah, you go to assembly there.
That is so cool. Unbelievable.
So we're quite ahead with the build schedule. Actually, you can see there's quite a few powertrains there. So yeah, we're moving on quickly.
Nice. I'm sitting here in the editing bay again, where our Inside AMG videos are being made, and there's just way too many great insights to get them into one video, so there's a little sneak peek. Stay tuned.